When Darwin received Wallace's letter, he reacted with a mixture of amazement and despair. It was as though he were reading his own theory, which he hadn't, of course, yet published. What should he do? Should he cede priority to Wallace, as honour seemed to dictate, or should he claim it for himself and risk a lengthy and unpleasant priority dispute? To make matters worse, Darwin's baby son was dangerously ill with scarlet fever and thought unlikely to live. In desperation, Darwin turned to his friends Hooker and Lyell for advice. And Lyell came up with a solution. Why not present the two theories together? The occasion chosen was a meeting of the Linnean Society here in what's now the Royal Academy in July 1858. Neither Wallace nor Darwin attended. Wallace was still in Indonesia, and Darwin was burying his son. This was the first time that the world would be told how life on Earth came to be. The papers were read in strict chronological order. First, Darwin's paper of 1844, then his 1857 letter to Asa Gray, and finally, Wallace's 1858 paper on the tendency of varieties to depart indefinitely from the original type. For such a momentous event, it fell as a bit of a damp squib. A friend reported to Darwin that the interest was intense, but the subject was too novel and too ominous for the old school to enter the lists without armouring. Even the president of the Linnean Society was one of those underwhelmed. In his end-of-year report, he said that 1858 has not been marked by any of those striking discoveries which at once, so to speak, revolutionized the department of science on which they bear. When Wallace heard about the readings, he was delighted. I not only approved, he wrote to his mother, but felt that they had done me more honour and credit than I deserved. Wallace never showed the slightest bit of resentment or jealousy of Darwin. He felt that his contribution couldn't compare with the authority and wisdom of Darwin's Origin of Species, and he was thankful that he had been instrumental in spurring Darwin into writing it. Wallace even coined the word Darwinism and described himself as more Darwinian than Darwin.
Darwin and Wallace were both men of science, more concerned with truth than commerce. But this was an era when science thought it could conquer the world. Faraday's electricity was paving the way. A new invention used electrical impulses to send messages over short distances. But it would take the ambition of William Thomson to unlock the global potential of this new technology.
When Thomson wasn't lecturing, he was in his lab, getting the help of students to experiment with telegraphy. That's using electricity to send messages over distance. It was the first real commercial application of Faraday's theoretical work.
The idea of telegraphy is that you translate messages into electrical impulses which can be sent down a wire and reconstituted at the other end. Today, we do this every time we speak on a landline, but then it was revolutionary.
By the 1850s, telegraph networks were rapidly spreading across Britain, continental Europe and America. But there was still one great unconquered territory, the ocean.
So Thomson took on an idea of real ambition: to run a wire under the Atlantic and connect Britain and America. The difficulties were immense. How to design the cable, how to manufacture it, how to lay it securely on the ocean bed. The combination of theoretical and practical challenges appealed strongly to him.
In 1857, Thomson joined the first expedition. But after only a few hundred miles, the cable broke. The next year, they tried again, this time successfully. But after only a month, the cable failed completely.
Thomson set to work on the problem. it seemed that the cable was just too thin for the signal to get through reliably. But there was one man he knew could help him. Michael Faraday, the guru of electricity. And by using his research, Thomson developed a cable which worked better, one with thicker copper wire and more insulation. He also invented a new piece of kit vital to receiving the signals.
Now, this is the galvanometer that Thomson built, and it's an incredibly sensitive instrument that can measure tiny fluctuations in electric current. Now, that really mattered because it was those tiny changes in current that were carrying messages in the cables under the Atlantic. So, to detect the messages, you would send the current through the galvanometer, and there's a tiny little mirror in there with magnets on it, and it would move according to the current, just a tiny amount. You'd bounce a light in, and the amount that the light moved when it came back out told you really accurately just how much current was going through.
Now what Thomson needed was a ship big enough and strong enough to lay the cable. And for that, he would turn to the work of one of our other geniuses.
The Great Britain hadn't been enough for Isambard Kingdom Brunel. He was consumed with the idea of an even greater ship, first called the Leviathan, then the Great Eastern. But to Brunel, she was always known as the Great Babe.
No one asked Brunel to build her. She was his own gigantic idea, a double-hulled, steam-propelled ship so huge that she could carry enough coal to sail to Australia and back without refueling. At 700 feet, she would be twice the size of the Great Britain and would carry 4,000 passengers.
Brunel persuaded the Eastern Steam Navigation Company to initially bankroll the project. But Brunel committed himself heavily, both personally and financially, and the ship would consume the last 7 years of his life.
The construction was recorded in this remarkable set of photographs. But from the start it was troubled. On the Great Eastern's first launch attempt, a labourer was caught by the handle of a winch and was mangled to death in front of a crowd of horrified spectators.
This is the last photograph of Brunel, taken aboard the Great Eastern in September 1859. You can see he's unwell, stress doubtless taking its toll. 2 hours later, he collapsed on board and was unable to make the maiden voyage.
On that voyage, bad luck continued to dog Brunel's Great Babe. Off Dungeness, an explosion ripped out the forward funnel, killing 5 stokers and injuring several others.
The news was conveyed to Brunel as he lay on his sickbed, anxiously waiting to hear of his Great Babe. 7 days later, he died.
But that wasn't the end of the Great Eastern. The prize for the successful transatlantic cable was still up for grabs, and Brunel's Great Babe, with her huge holds and manoeuvrability, would win it for the Atlantic Telegraph Company and for William Thomson. Soon, underwater telegraph cables would span the world, enabling communication between Britain's far-flung imperial possessions. Previously, it would have taken long, hard weeks for a message to reach a foreign country. Now, it could be communicated in moments. This had far-reaching effects for catching criminals, changing businesses, and speeding up diplomacy. William Thomson's work on the transatlantic cable brought him a knighthood and more. He became Lord Kelvin, but more was still to come.